Hello, puppies, kittens. Welcome to another episode of Matter of Fact Science. So I was working on, for whatever reason, I've done, the evolution of pterosaurs and evolution of turtles and the evolution of people, of course, and a number of videos like that. And for whatever reason, people have recently been sending me message saying, "Hey, you should be doing the evolution of snakes." I said, "Okay, well, I'll do that." It's an interesting story, and so I start researching the evolution of snakes as I do this script. I want to write out everything, make sure it's all accurate. And I'm following the notes, and I keep finding the same name coming up over and over again.
Write out everything, make sure it's all accurate. I'm
Oops.
following the notes.
I'm getting an echo for whatever reason. Okay, good. That's ended. So anyway, I saw this presentation by Michael Caldwell, who seems to be the foremost expert or the go-to guy when it's talking about the oldest of all snakes in the fossil record. And indeed, almost every study that I looked into to reference in making these notes all had Caldwell's name on it. And I'm like, I need to talk to this guy. And when I reached out to meet with him, he mentioned that he, like me, is a former Mormon, which was not included in the message I sent. So that was encouraging. He seemed to know a little bit more about me than the invitation, and I was delighted that he's accepted. He said he would be happy to come on and talk about the evolution of snakes or whatever. So, my pleasure to introduce Michael Caldwell. Welcome aboard, sir.
Hi, everybody. Pleasure to be here, Aaron.
Also joining us, my wife Lalandra, of course, and I've also invited my friend Larry. What's your last name? Mendoza. Larry Mendoza is he wants to clarify himself as an amateur herpetologist, but he does give presentations on herpetology. He has a bunch of snakes. How many snakes you got, sir?
I have around 40 right now.
40.
So your collection is about half of mine right now, Aaron. You'll get to where I am pretty soon.
Okay. Probably well, I hope not.
In a couple of days.
Because I've seen a couple of posts from him where he admits to having been bitten by a viper of his or whatever.
Larry, weren't you president of the Herpetological Society?
Yeah, I was I'm a past president for the Virginia Herpetological Society, and I currently serve on the Educational Outreach Committee.
So my thought was, we've got Caldwell on here. You are the expert on... And you were the one that discovered. You have credit for discovering the oldest snake in the fossil record, do you not?
Well, credit is always an interesting one, Aaron. If you ask the people who agree with me on what it is that defines a snake going that far back in time, then yeah, I'm the guy who gets credit for at least writing the paper on the oldest known snake material from the fossil record. But then, of course, there'd be some people on the other side of the coin that might hold that it's not quite a snake. Maybe it's a stem snake, or maybe it's not a snake at all. There are always those sorts of fine-tuned arguments about what makes a snake a snake.
Oh, let's start with that then, because I remember I got my ass chewed a little bit years ago when in 2015 when they found Tetrapodophus. I made a video that I was approaching it from maybe it's a snake, maybe it's not, but if it is, but even if it isn't, it's so close to the crown of snakes that it doesn't really make a lot of difference, but people just chewed me on it. So that's the first thing we should probably ask you. Dolichosaurs. If you had the genetic, let me see if I can speak correctly. Genetic studies show the varanids, specifically the monitor lizards, as being the closest living relative to snakes. And of course, we don't have genetics for dolichosaurs. In your estimation, if we had the genome for dolichosaurs, would they be within, or would they be even closer to snakes than monitor lizards are?
Well, I'll start. We'll tackle the nucleotide and genomic thing here first, Aaron.
It's Aaron, please.
Aaron. Okay, sorry. And we'll tackle that first. It's an iceberg. Let's put it that way, so that what we're really talking about is the 5% of that iceberg that's poking up above the water, and that's really where we're at when it comes to nucleotide data sets, even how much of a gene that we actually sequence, right? But regardless, the current phylogenetic hypotheses that are based on nucleotide data, there really isn't much of whole genome stuff out there right now, wouldn't place snakes as the closest relative of varanids, specifically within that varanoid anguid radiation that everybody talks about as anguimorph lizards. Rather, snakes would be in a clade with that anguimorph radiation that's also most closely related, of all things, to iguanians in a group that's referred to as the Toxicophora. That's what the molecular data has been signaling almost consistently and without differentiation since about 2000 and when was the Vidal and Hedges paper? 2004. And that was based on a couple of gene loci only, the RAG1 and oocyte maturation factor loci.
Well, help me with my confusion then, because I've read like 3 different studies that said it was the monitor lizards with the closest.
Before we go there, like my background is in science communication and former science teacher, stuff like that. And for people that are lay people, you said
iguanians. So that's iguanas.
Iguanians.
Yeah.
Okay.
Sorry. Yeah.
So you're saying
including your bearded dragon.
Including the bearded dragon. You're a gamete, your bearded dragon. Is a member of that large iguanian group. It includes things like the green iguana, your agamid lizard, your bearded dragon, and chameleons.
Fence lizards, things like that.
Fence lizards, that whole lot.
Set the scene here. So, like that particular grouping, the iguanids, and not like aren't seeing the monitors. Where did this start in time? How far back in time are we going?
Well, okay, so all of this is so that's the molecular side, the Toxicophora hypothesis, because believe it or not, your gamete actually has some slightly venomous spit. Enzymes in the salivary, excretions are mildly toxic, and the enzymes aren't exactly similar to the kinds of things that we see in the mouths of varanids like Komodos and other varanid lizards, nor are they identical to the sorts of enzymes and the potency and toxicity that we see in venomous snakes, but they are there. And that molecular signal, Iran, I don't know exactly what studies you've been seeing that linked Varanus most specifically to snakes. I'm certainly not familiar with that, though I am familiar with the larger scale studies that have been finding snakes, iguanians, and that whole clade of anguimorphs to be lumped together to the exclusion of all other lizards. That I'm familiar with.
Okay, so now that lays into the next thing.
Hold on a second. But with monitors like the Komodo dragon, at first they were saying the toxicness of its bite was bacterial, but then they were starting to say perhaps it has some sort of venom.
Yeah, and
that is Brian Fry's work that
it's Brian Fry.
Yeah, he discovered the venom properties of varanid, the Komodo dragon and other varanids.
Yeah, well, I could have told him that because when I got bit by my own monitor lizard, I realized immediately that's a hemotoxin.
Yeah, they have them. I mean, we do too. Any salivary excretion is an active enzyme. That's what helps you.
I often tell people that we are venomous to potatoes.
Yes. Yeah. And it's oddly wasted in the iguanians, in the green iguana, in the bearded dragon, and in chameleons, because they sneak up on fruit or they've got a sticky tongue and they catch bugs.
Yeah.
So it's odd that it's there, but it's there. But that isn't the data that has put those 3 groups together. Well, it's really molecular data sets that are doing that, and that signal is consistent right now.
Well, then we need to compare notes.
We should compare notes on that, Iran. I'm curious.
Yeah. We're a bit jumping ahead on that because maybe Arn had a question. I don't mean to give away his questions, but maybe the common ancestor of snakes and some of these other lizard groups was venomous, and venom originated there. or maybe that's some kind of like parallel evolution in different lizards.
Yeah, I see these as being, there's commonly debated questions. There's a handful of them on the origin of snakes, and I don't see them as equivalent questions. I see one clear answer. I mean, and maybe it's wrong to think that way, but when I see whether, for example, whether what is a good example on whether snakes were venomous at the onset, or whether snakes started out as swimmers or as burrowers. That question, one of the many debates there. I think, okay, we've had two, where we've had one that's definite sea snake, and then two others that maybe were sea snakes, and then one that was a definite burrower, and those are way early. Those are like 100 million years ago.
Mm-hmm.
But then if you look at all of the collective modern snakes, you don't start seeing snake 1 until you get into the advanced ones, until you get into the colubroids.
Right. Way high
and
up.
You have all of these other clades. They're all burrowers.
Well, burrowing's an interesting one, and we can tackle that. I'm happy to launch into that. Just about anything out there that's legless can dig a hole. Whether that means it's a burrower, and whether burrowing is then primitive for the group, is another question altogether. Even if you find what you think is the most primitive living snake, that doesn't necessarily mean that you have any insight, 100 million years later or 170 million years later, on what the ancestral habit was of ancient snakes. You really don't know that from crown group snakes, from living snakes. That's where you need to understand who the potential closest relative is of snakes among other lizards, in order to be able to get a sense, by then reconstructing what their common ancestor would be like, to give you some insight on that ancient ancestral ecology. And I tackled this in my book in great detail, going into exactly the problem that we face when we try and create origins scenarios in the absence of having a robust, what we like to use in the business, a sister group relationship hypothesis. But you can think of it too in terms of closest relatives to the group that you're interested in. You really need to have that before you can hit, is it a burrowing ancestry or is it a marine origins?
And another hypothesis, I think, is that whether it's not just whether it's fossorial or marine, or it's also arboreal.
Our boreality would have been there for sure, Larry. And a really funny thing, I mean, Ron was talking about how careful he is to make sure he's citing the literature. Here's one that's really critical, and this is something that I talked about at length in the chapter in my book where I dealt with origins hypotheses, and really dug deeply into how these got started and the myth structures that people really like, that are inherent in these scenarios, that have nothing to do with what actually was written about in the literature. And the accusation for the marine origins hypothesis is exactly that. It goes back to misquotations of Cope's work from 1869. And if you read the literature from the burrowing origins side, you would think that, well, Cope was the guy who came up with the marine origins hypothesis. No, he never actually said that once in anything he ever wrote up until the day he died in the 1890s. But it was a misquotation and a miscitation by his detractors. And he became famous and then miscited all the way up to the present for having presented this hypothesis. What Cope really said, when you go back into what he wrote, was extremely simple. He said, based on the anatomy of what I see as mosasaur and what I see as snake and what I see as other lizards, the anatomies are shared more by snakes and mosasaurs than either one of those is shared with any other kind of lizard. So he almost had a modern cladistic statement in the way that he was basing it on the anatomy. But he never once created a scenario where he said, and therefore snakes evolved from some kind of marine ancestor like a mosasaur. He never said that once. And this becomes our problem. And you know what? I've been accused of being the person who resurrected Ed Cope, along with my colleague Mike Lee in Australia. And guess what we wrote? We never wrote anything about a marine origins hypothesis once. We just simply said, in our phylogenetic analyses, snakes come out as the sister group of Mosasaurs. And that was immediately interpreted as a marine origins hypothesis, which it isn't. And so, in fact, what we did way back in 97 and 98 is we proposed 3 equally possible and plausible scenarios. It could be that they shared a common ancestor that was marine. It could be that they shared a common ancestor that was a burrower. It's also probable, and the one that I still hang my hat on, that while snakes and mosasaurs might be closely related to each other, and this would include the dolichosaurs, Aaron, what's probable and almost absolutely necessary is that both of them had 4-legged terrestrial ancestors, none of which were marine. Yeah, they were all terrestrial lizards of a kind, moving in their evolutionary trajectories towards snakeness on the one hand and mosasaurness or dolichosaurness on the other. So that there is no burrowing origins reality nor a marine origins reality to any of this. And I've never actually written it, but I am, if you ask, the popular press, oh yeah, talk to Mike Caldwell. He's the marine origins guy.
I didn't get that impression from your presentations or from your papers. You definitely seem to be going professorial.
Terrestrial, yeah, definitely a terrestrial origin.
And I have to agree with that. One of the arguments that I made based on your work was that yeah, we do have at least one a Eupatosaurus. I think Eupodophus.
Eupodophus.
I'm sorry, how do you say it?
Eupodophus. You had it right. Yeah.
Okay, so that one's definitely a sea snake because it has the flattened tail into a fin, so that makes sense. The other two may well be. The only way that they can estimate that is by the whether it's just like a, not a swampy, but it's a coastal sort of a region of shallows. So is it a land snake? Is it a sea snake? We don't really know. And then we have Tetrapodophus, which is definitely a burrower. And for those who don't know, Tetrapodophus is talking about a snake that has 4 legs, which was originally called a snake, but was later determined, I think by yourself, that this is not a snake.
Yeah, and it's definitely not a burrower either.
It's not a burrower either.
No, it is definitely not a burrower.
This is what I get from reading the literature. I've got a citation that actually says that it was a terrestrial burrower.
Yeah, I know. That's probably the 2015 Nature paper by David Martill and company. Our rebuttal to this was just published. I guess it'd be about a year ago now, November of 2021. And what took them 5 pages to create took us, I think it's about a 60-page published page rebuttal. And we went through the thing anatomical feature by anatomical feature. This is one of the problems with the fossil record. Determining paleoecology from something that you can't see living and acting in its environment is extremely difficult. And one thing that's really true about the fossil record, there isn't a single preservational environment, a single sedimentary environment in the rock record that isn't deposited in an aquatic environment, with the exception of wind-blown sands. So, what the geologists like to call aeolian deposits. Tetrapodophus, as an example, Aaron, is found in what's best described as probably a hypersaline lake system associated with rifting along the margins of Brazil back 120 million years ago. So while it's possible to preserve a bird in a lake sediment or a butterfly, which means they weren't living there, and you can tell from their wings that they were probably flying, we find Tetrapodophus has an anatomy where the tail is very flat and tall, just like you would expect from a tail-driven swimmer. The limbs are extremely tiny. The animal is skinny and it's incredibly small. I mean, the whole thing is, no bigger than this pen. In fact, the pen's probably a little bit longer. How to determine burrowing from the anatomies that are preserved? I can't. And from the sedimentary environment in which the fossil is preserved, it's in a lake sediment. Do we generally find burrowing animals in lake deposits as fossils? The answer is no, we generally don't. Those kinds of terrestrial organisms are badly preserved in the fossil record, if not at all.
This is frustrating for me because when I originally scheduled this with you, I'd intended to have these videos already out.
Oh yes.
And then I would be talking to you. But now that I'm talking to you and you are upending so much of what I've already written that I have citations for.
Oh yeah. Well, they're valid citations.
I was convinced
science and how science gets very confusing for people. We wonder.
Yeah.
There's always this is frustrating, and science
He's
is
rewriting paragraphs with every sentence.
Worry about that.
Everything you say,
it's a good thing that you haven't written the script or you haven't finished,
isn't it? Yeah, I would be so embarrassed at that.
Maybe the confusion, to circle back to it, with varanids and snakes. Maybe you mentioned mosasaurs, and mosasaurs. Some of them, like Dallosaurus, we're here in Dallas. They have some kind of morphological similarity to varanids and monitor lizards, even though they had.
I think Dallosaurus was technically a mosasaurus. Like, isn't it the earliest unambiguous mosasaur?
Well,
they have flippers.
Yeah. Not quite, but I'm aware of the argument. Let's put it this way with respect to Dallosaurus. One of the problems with Dallosaurus is that it's not quite what I'll call a chimera, but it is not represented by an articulated specimen. It's a whole disarticulated bunch of remains that were cobbled together using as much comparative anatomy as you can in order to put it back together. But it's extremely incomplete. And as a result, there's a margin of error in there that's probably a big margin of error. It is a mosasaurine of some, or a mosasauroid of some kind. There's no doubt about that. There are much better preserved and geologically younger specimens of similar sorts of animals.
Aegialosaurus?
Aegialosaurus.
Aegialosaurus. Okay, thank you. Because I've only ever read these words. It's nice to hear them pronounced.
Well, and let's be clear, it is Latin. Who knows what it's really supposed to sound like, right? We can do a little bit better with the Greek. But in any case, the similarities between mosasaurs and varanids, this is another point of contention. Oh. And I've been at the center of that point of contention for some time. 90% of the animal, a mosasaur, that is a lizard. And of course, any similarities that you might find between varanus and other lizards are bound to be shared by mosasaurs. One of the principal comparison points that are used, or has been used for a very long period of time, is that the nose of a mosasaur is quite long, right, and narrow. And so is the nose of a varanid. The character that has been created out of that anatomy to sort of summarize all of it and suggest that they're similar to each other to the exclusion of other kinds of lizards is what's known as a retracted narial opening. The problem with that is that it's such a simplification of the anatomy that when you actually take the nose apart, you've got about 8 or 9 bones in the snout that are associated with that opening. And varanids make their opening in a very different way than mosasaurs do. So just having a long, skinny nose and, metaphor I've used in published papers is a donut hole. And if you're familiar with topology and math, you'll know right away that you can make a donut into a coffee cup, no problem. It's one of those, endless variations without creating an extra hole that you can use with the material. And so if we take that similar notion of topology and go back to the mosasaur nose and the varanid nose, but break down the elements that are independent in that nose and that could potentially, in the way that we understand evolution and interpret evolutionary change in relationship to homologies, then you will see that the mosasaur nose is not the same kind of nose as the varanid nose at all.
For context, we're talking about a mosasaur, which they're different sizes, but they could be these huge marine lizards. But with the thing you obviously have been reading and researching this way more than I ever will in my lifetime, but and discussing it with your peers who
not only that, he's been in the field.
But I was seeing some small snippet that maybe mosasaurs and snakes, they both had forked tongues. Is that a
so there are a number of living lizards that have forked tongues.
Yeah.
We don't really know what a mosasaur had for a tongue. A varanid certainly has a long forked tongue, and on the outside it looks very similar to the kind of forked tongue you'll see in a snake.
Yeah.
But structurally it is different, and it's housed in the mouth in a different way than snakes house their tongue in their mouths too.
That's interesting.
And if you search around, probably there are about 11,000 living species of extant lizards, and I include snakes when I say that because snakes are a kind of lizard. And then in that higher group, and the jargon word for the higher group would exclude geckos down at the bottom of the tree, along with iguanians. We have the scleroglossans, which means scaly tongues. And amongst those scaly tongues, which includes snakes and varanids, for example, there are probably conservatively about 9,500 species that have forky tongues of one kind or another. So the forked tongue thing is actually pretty common across most of what we think of as lizards, to the exclusion of iguanians and geckos.
So when you're talking about that, we know that the varanids have forked tongues. We also know that the Gila monsters have forked tongues.
It does. Yep.
So you're saying there's not a synapomorphy there?
Oh, there definitely is, but the forked tongue of a Gila monster, a varanid, and this obscure thing from Southeast Asia, Lanthanotus borneensis, they're pretty similar, and that condition is considered synapomorphic among those three. And then there are similarities again at a lower and much more inclusive level with anguid lizards. The legless anguids, the legged anguids from North America, they're pretty common around here. The Garanotes,
like the alligator lizard.
The alligator lizards, yeah, that same lot. But the forked tongue, if anguids, sit somewhere at the base of the radiation that gives us varanids and varanoids, then snakes are outside of that.
Okay, so since you are forcing me to rewrite my entire script.
Oh yes.
Then let's just go over one other thing that I'm just going to go ahead and call attention to.
Sure.
On the assumption that the thing that I read that showed that said that it was genetic studies that varanids are the closest living relatives to snakes.
Yep.
Assuming that to be the case, and Cope came up with Pythonomorpha, wherein he lumped in mosasaurs with snakes. Mosasaurs that was excluding varanids at the time, right?
It was. Yep.
Okay. If Pythonomorpha, it seemed to me, if Pythonomorpha included varanids, excluded iguanids, and maybe excluded Gila monsters as well, then genetically, if in fact it was that the monitor lizards are the closest relatives of snakes, genetically, wouldn't the change in cladogram still look the same? I mean, iguanids would still be the outside, monitor or Gila monsters would still be on the outside. Yep. But if varanids are included with mosasaurs and dolichosaurs are included with varanids or alongside them, that phylogeny would look the same, would it not?
Yeah, in really broad terms, you're absolutely right. The question always comes down to what people are hunting for when they're either using molecular data or morphological data? Are you really just hunting to get an approximation, in other words, a relative answer, which is, I think, what we do in science and what makes science continually testable via falsification, to be honest? And I'm not a strict Popperian, don't get me wrong. But if you're comfortable with relative statements, then we're all just looking for who's more closely related to whom, not who's the ancestor of whom. Ancestor descendant statements are absolute statements. You know, you're either the grandson of your grandparents or you're not. And we think of things in really concrete terms when we use that ancestor descendant language. And in that sense, if we're content to work with the data sets that we've got, then the relative series of hypotheses or the relative series of answers that currently exist on this would say that the group that includes Varanus, not Varanus specifically, but that larger group, is close in its relationships amongst all other lizards to both mosasaurs and snakes somehow. I'm totally comfortable with that. It's when instead the criticism or the debate begins to rage. Well, no, absolutely not. Snakes aren't close to mosasaurs because mosasaurs are a kind of highly derived aquatic Varanus. And some ancient Varanus is the ancestor of both. Nope. That's where I'm going to get my backup, because now we've stepped outside of the realm of ideas that we can test and that new data can falsify, or that new hypotheses can challenge, and we've moved to those concrete absolutes of, nope, that's your grandpa and that's your grandma, and the question's done.
Yeah, well,
So
I
in
look
broad terms, you're right. All of these things are in a group, Iran.
I look for how many things are consistent.
Yep.
And supported.
Yep.
And on the thing about, you know, whether I liked Cope's idea of Pythonomorpha based on anatomy and the genetic thing, if the phylogenies are correct. If it shows that varanids are closer than iguanids are, then Pythonomorpha makes sense to me. And there's just something, I don't know, call it nostalgia if you like. I like when there was a guy, William C. Beebe, who was studying Archaeopteryx and realized that Archaeopteryx had flight feathers on the back legs. And he said, based on that he predicted there would be another fossil found that was just as Archaeopteryx is intermediate between dinosaurs and birds, there would be another one that was intermediate between birds and Archaeopteryx, or excuse me, dinosaurs and Archaeopteryx. So there would be another link there. He described it perfectly. And 100 years later, to the year, that very thing was found.
Right.
But for whatever reason, it wasn't properly identified, and the name wasn't corrected. For whatever they called it, Microraptor. They should have called it Tetrapteryx, because that was what it was named 100 years before it was found when it was predicted. And I think the honor should go to the guy who predicted it would be found.
Right.
So I prefer what is supported. I like the nostalgia of somebody makes a correct observation and it is borne out. He's shown to be correct. And so I wanted Cope to his classification of Pythonomorpha. I wanted that to be fruitful, more so than say when like Harry Seeley and Richard Owen, when they come up with Dolichosaurs and they want to make that strong distinction between the Varanids and Dolichosaurs, and they're not looking at it cladistically. Certainly Owen wasn't.
No, of course they wouldn't be.
You know, and Seeley had all kinds of ridiculous ideas. He thought that birds evolved from turtles, among other things. So, you know, I question both of those guys.
But like, to go back to this, and I don't mean to be stuck on it, but it seems like that the forked tongue is like a really important sensory organ that helps some lizards to smell. And if iguanids don't have one, but monitors and snakes have one, and I don't know if monitors use their forked tongue in a different way. Like snakes, they use it to touch it to their Jacob's organ to figure out what things smell like, you know. But then it just seems like one of those structures, and it's a soft structure, so it's hard to tell because mosasaurs, you don't have that many.
The Jacobson's organ system is present in all squamates, along with the perforations in the roof of the mouth. So they all use the tongue in some form or another.
Exactly. Whether it's forked or not,
whether it's forked or not.
Right.
Yeah.
Mm-hmm.
Yeah. It's a chemosensory system that
Right.
doesn't depend on the forked tongue. It
Now
just
the
needs
fork,
to stay
the fork
wet.
is for lack of a better analogy, it just means stereophonic, right?
Perhaps. Yeah, perhaps. And
That's
you know,
what I think. That's what we think. That's what it's used. Yeah, for stereo.
Because I understand the tegu also has a forked tongue,
it does.
but it's not as close to varanids as iguanids are.
Oh, well,
No, they're not. In fact, it's there's remarkable examples of convergence across the lizard crowd, the squamata, and that forked tongue is just one of them. But
that's the
tegus,
thing I was going to say is that there's a lot of convergence that goes on, and whether there's a genetic basis for convergence or not. I mean, clearly there's got to be some toolbox gene out there that is easily swayed one way or another, right?
You bet.
But that's what makes this really tricky, is because it's the same thing with venom evolution. How many times has venom evolved within the snakes themselves, or is it hasn't been linear? So when you're looking at convergence, now we're adding in a whole level.
One of the studies that I'm citing in my script says that there's genetic evidence that there's morphological and not morphological, embryological, and genetic evidence that in Lamprophiidae that venom and fangs were selected for and against over and over again.
Yep.
And I get confused as to how that can happen.
And different types of fangs, right? Because when you look at your rattlesnakes and your vipers versus your elapids, you're looking at two different, very different fangs systems.
Before we get any deeper into this, because I feel that's what we're about.
That's a whole other. I'm
talking about a paleontological expert in this field and a herpetologist at the same time, and I'm coming out looking like the dummy here. So I fear what the audience is going to feel like. I see two questions set up, and the way we would normally do this show is we would have our guest talk with us for a half hour, and then we would have him answer selected questions from the chat for the second half hour, unless you feel good about going longer than that. But I don't see but two questions. And I'm happy to throw those up, and maybe we'll just continue talking until more happen. But let me read those. I want to get into this discussion that Larry was just about to bring up. I really do. But I don't want to abuse the other people either. So Corey Neidham offers $9.99, says, "Hey, Mike, pleasant surprise to see you on YouTube. Happy holiday season."
He's the son of one of my collaborators and a close personal friend. You will have seen his name on a bunch of the papers you were reading around. Randall L. Neidham. That's his son, Corey.
Okay, very good. And
great question.
Yeah, I know. Happy holiday.
And then Jason Bratt says, "What about skinks?"
I think he was referring that to when we were talking. I thought I saw that pop up when we were talking about the tongues.
I mean, it could have been when we were talking about diminishing legs, because skinks are kind of famous.
Oh yes,
for not giving a shit about if they have legs or not.
Yeah, or every version of leglessness and limb loss and toe reduction, front and back, that you could possibly want to shake a stick at.
Yep.
Larry's probably familiar with the genus Larista from Australia. Last time I looked, and you might have a better number, Larry, as you pay more attention to the living stuff than I do. But the genus had about 140 species assigned to it, give or take a few. And you have everything from 5 toes, front and back, and a perfectly formed, skinky-sized leg, to completely legless forms, where even the pectoral girdle is gone now, to a humeral spike with no lower limb bone whatsoever on the front leg. And thus no toes at all, and 2 toes on the back, 3 toes on the back, no forelimb at all, 2 toes up front, 1 toe in the back. I mean, it's everything you could possibly ask for. It's a wonderland, honestly, within a single genus, on how to understand the convergent loss of features, this could take us back to the Lamprowphiidae, the convergent loss of features in one single genus, because they're clearly not just going legged to no legs, they're just off and running. And
let's not forget live birth versus
oh yeah, viviparity versus oviparity. Yeah.
So you can have one species of skink, because I understand that there's one species of skink that and even in rare cases, one single individual that will lay eggs and then give live birth later.
Sure.
And then flip back and forth.
Yep. Yep.
I don't know where to
Convergence
go
is more
from that.
common
Larry,
than anything else in evolution.
And it goes to speak to, some of these toolkit genes that can be turned on and off so easily depending on selective pressures that, and it really does make a mess out of systematics and cladistics, because it makes it very difficult to really, what came, chicken and egg, what came first, the leg loss, or did that evolve how many times, things in that genus. Yeah, it's absolutely prime example of that.
I'm going through the chat and I saw a couple of questions that weren't saved, but they were repeated. And one is, do all snakes have forked tongues? And the second question was, how did the forked tongue evolve?
Do all snakes have forked tongues is a little easier than how did the forked tongue evolve?
I mean, I can answer that question. I'll let you take the other half.
Yeah.
Because that question's come up at least twice that I've seen so far.
The one group that's a little problematic on the forked tongue thing, though, are the Scolopophidians. That's the extant group of truly burrowing snakes. There are a couple of hundred species.
Those are the blind snakes?
That's the blind snakes. And they really are burrowers, and they define what you would like to think of as, fossoriality. But they're the one group that doesn't have exactly the longest forks on their tongues. But they're underground in ant burrows or ant hills and termite mounds for the most part, though they do get out at night in order to reproduce and move about. So they're burrowers by day and burrowers by predatory habit. Though again, there are anecdotal stories on these things. They've been found in tree bark, hunting for burrowing bug larvae. Does that make them arboreal, Larry?
But that's not a far stretch, right? Because they're still burrowing, but
exactly
burrowing, vertically as opposed to horizontally.
Yeah. No, I'm totally with you. But that's the one group that out of all of the 4,000 some odd species of extant snakes don't have the classically long forks on the tips of their tongues. Otherwise, they all do. Where that forked tongue came from is an awfully good question, particularly if the Toxicophora hypothesis, the molecular side of it, is even mildly accurate.
Well, then let me ask you about that, because I'm fond of Toxicophora. I've been apparently saying it wrong too. Toxicophora.
I say it for Mike's convenience, Ron. Heck, if I know if it's right.
So Toxicophora, I'm okay with that, except for the premise that it implies that iguanids had venom, meaning that the bearded dragons had venom, because bearded dragons, agamids, are a subset of iguanids. The Gila monster and the monitor lizard are both anguomorphs. They both have venom, much stronger than what the iguanids have. So, and the snakes, if they come down somewhere in between those two, then they must have originally had venom too, which means if you track back, then snakes came from a 200 million year old ancestor that already had venom. Yet the fossil record implies that venom was not expressed. A propensity for venom was supposedly existing in these for 150 plus years and wasn't actually expressed in the fossil record until 25 to 50 million years ago at most.
Yeah, that'd be pretty accurate.
So that doesn't seem to be the case, does it? It seems like venom production in Ophidia, or did I even say that? Yeah, I think I did. Venom production in snakes didn't happen until we get into colobroids.
That's absolutely where we see it distributed amongst the crown right now. Yes. So the crown being modern living snake forms. You
Why
don't
don't you
see
let me ask
that
this
level of the Colubroidia.
Let me ask you this then, since to play on your expertise here, you found some of the oldest snakes, and I want to mention something else, but make my question a little bit probably unnecessarily long. There were a handful of snakes that were known to have two legs. Eupeitosaurus, Hasiophysis, Pachyrhicus, just a handful that were known to have two legs. They were the back legs, and there's no sign of a shoulder girdle. There's no sign of front legs at all.
Mm-hmm.
But all of those were found between 92 and 100 million years ago.
Right.
And then you found two, or you wrote about two species from 144 to 157 million years ago.
Yeah, and there are 4 actually in there, but yes. Yeah.
Well, we do need to compare notes.
Yeah.
And they were limbed, right?
And sorry?
They were 4-limbed, the ones that
Well,
you
we don't
found?
know.
Okay.
We have absolutely no fossil information whatsoever.
That gets to my question, because you've got a skull and you've got a piece of vertebrae, or a section of vertebrae, and that's enough to tell whether you're talking about a snake, is it not?
Yes, it is. Yeah.
Are we talking about the Portugalophus?
Yeah, Portugalophus, Diablophus, Parvoraptor, and Neophis. Yeah.
And Neophis, okay, yeah.
Diablophus. You wouldn't. I don't even want to tell you how I was pronouncing that before I heard you say it.
Yeah,
well, you could go Diabloophus too if you wanted to.
Okay, that's what I was doing.
All right, yeah.
Wait, before we go further, I have a layperson question. The Toxicophora hypothesis, is this hypothesis the gist of it that that snakes evolved from a venomous ancestor?
No, it's only that the 3 groups that the molecular data puts together in the phylogenetic hypothesis that's based on that molecular data, that those 3 groups all actually have somewhere in their membership venomous species. That's the Toxicophora is actually a terrible name because it makes it sound like venom was inherent in the evolution of that group, and it's not, and that's not what was inferred either. It's that the molecular data says that these 3 groups are closely related to each other. It just so happens they all have venom somewhere up in the top of their family trees, but it's not that venom was primitive for the group. No.
Let me ask you if there's a term for this. I feel that there should be. When you get into squamata, I've read that squamata can be identified as having this tendency or propensity to reduce or lose limbs. Mm-hmm. It's just one of the things that, like, often but not necessarily always happens. And it doesn't have to be that it's not a direct synapomorphy. It's not that they're already on a course to lose legs. It's just something that more likely is going to happen in that group than, say, in Rhynchocephalians, for example.
Yep.
Right, it's going to happen more in squamates. So what do you refer to as something like that, where you have a propensity for venom that is more likely to occur in, let's say, the pythonomorphic group, or the toxicophoran group? You have this propensity for venom that's much more likely to occur here than in any other squamate group. Is there a term for that kind of edge on the roll of the dice?
No, I mean, I think Steve Gould at some point or another probably used the term exaptation in making reference to this, that, prior to the feature really evolving and being used for a particular function because of its pre-existing ground state, I guess might be a way to phrase it. It would be exapted for that future adaptation.
That may be the word that I was thinking.
Yeah, that would be the closest one I would kind of dredge out of the depths of my head, because it's also been years since I was reading Gould or up. Yeah, exaptation. But I don't think we tackled that question you had about Parvoraptor and Portugalophus and that lot either. You were wondering about how one can recognize snakeness in the absence of a complete body fossil of a snake. And that's probably where you were headed with that question. Is that,
Yeah.
am I remembering that
The
correctly?
pictures I'm looking at for those, they're artist renditions, but they show hind legs, but not front legs.
Yeah, never trust an artistic reconstruction.
No, I know. But that's the way they're being portrayed.
And I can tell you why, Larry, because I was the guy who told the artist what to do.
Yeah, and that's the thing, because I use these pictures in one of my talks.
Yeah,
I should show you.
Snake,
I've seen plenty of artistic renderings of Spinosaurus.
Oh yeah,
from the 1990s.
Yeah.
And you can't imagine how different they are.
I'll try and tackle this one, Iran. Then I'll give it a whirl, and I'll start with what we were talking about here just a moment ago, and you mentioned that exaptation notion, and in the context of Toxicophora and venoms. I'll take the same idea and back it up. Nobody out there thinks that snakes are not a kind of lizard. All right. Amateur herpetologists, professional herpetologists, paleontologists, and probably most people walking down the street, if they have some sense at all of what snakes are, would probably expect that they'd be a kind of lizard. I have met a few people who think they're a kind of worm, but that's an extreme version of, I'm with you, Larry.
I have to tell you, I talked to one of my son's science teachers.
Oh, no.
Who told me that snakes were invertebrates.
Oh.
Because they had no spine.
Okay, well.
They're basically all spine.
Okay. Well, because they're a kind of lizard, we'll just go back to that part of the conversation.
Of course, that person also thought that the very first snake could talk.
Oh.
Yeah, well, yeah, right.
There are lessons for that in certain books. Yeah. But in any case, that means lizards had 4 legs. All right. And, snakes had 4 legs because they're a kind of lizard. And as we understand lizards, primitively, they have 4 legs. And there was a question about skinks and Larista. I raised Larista as an answer to this, or to point out how much convergence there would be. And what we see in lizards is that when an organism loses its limbs, like a legless Larista, we can still tell that it's A, a member of the genus Larista, and B, a kind of skink based on its head. You can take the head off of a legless Larista and the head off of a limbed Larista, and I challenge you to tell me which one you've got. You're going to need a great deal more than just the details of scalation, even on the head. And the cranial anatomy, you're not going to see a single difference between those 2 species of the same genus. And this is true for all skinks, because there are lots of other genera of skinks and subfamilies of skinks that are legless. But you can tell they're a skink because they share common features of the skull that make skinks regardless of whether they're limbed or limbless. And the same thing holds true for the legless anguids, Pseudopus apodus, Aniella pulchra. You can tell which ones these are. You can tell they're an anguid because of the way that the skull is built.
I know that you said that either, if not in you said that in your presentation.
I did, yeah, and in my book as well. I went over this, and we can do the same thing with the legless gecko groups, the pygopodids. You know exactly what you're dealing with based on the skull. So if snakeness and limb loss in snakes is not unique among lizards, in fact, limb loss appears to happen all the time. Alan Greer wrote a couple of papers in the early 80s where he identified in extant squamates, in extant lizards and snakes, 65 high-level versions of limb loss across all of the lizard families and snake families. So in fact, then, if we're going to go back in time, one of the things that makes living snakes unique is that there are no limbed forms among living snakes, whereas all the other lizards, they have limbed forms. And we can tell right away, oh yeah, that's a legless anguid, or that's a legless gecko, or a legless skink, because we got other living forms. This would tell us then that snakes lost their legs or started the process of losing their forelimbs and rear limbs and becoming long and skinny because the 2 work together. It's one of those stacked mutation schemes that once it starts, you also get long and skinny once you start losing your limbs. that it had to happen a long time ago, and that we're going to have to look into the rock record, the fossil record, to find examples of snakeness. And it'll be snakeness at one point where you have all four legs and the animal is short. Its body's going to be short. And what do we learn when we look across the rest of the lizards? Well, we learn that you can use the head to tell you when it's an anguid or a skink. And we should be able to use the head to recognize snakeness in an animal that isn't long and skinny and limbless. That's an argument of logic. We could write the algebra. I mean, we could do it that way too if you want. But that's basically what we did with the Parvoraptor paper, that same one that Portugalophus, Diablophus, and Eophus are in. What is it that we should be looking for 170 million years ago in rocks that are of that age that will show us what snake skull anatomy was like? I would expect at some point to find a four-legged snake. Tetrapodophus was not a snake. That's just an aside, but you kind of get the argument. And so that's what I went hunting for when I was looking for bits and pieces in museums drawers from around the planet. What does a snake maxilla look like? The upper jawbone. What do snake teeth look like? We've been good at it with vertebrae, but we've been crappy at it with skulls, because for some reason, hunting for snakes in the fossil record has historically been a hunt for long, skinny, and legless. And you know what? We're not going to find that. We're going to find partial skulls, and maybe one day we'll get lucky and we'll get some middle Jurassic completely articulated snake. But I'll bet $5 it's going to have four limbs. I'll bet it's going to have a short body, but it's going to have a snake with snake adaptations of the skull, just like we see in modern skinks.
That's one of the lucky things about paleontology, teeth, because they happen to be covered in a very hard surface and they're very derived. So that's how you can look at a skull and go, these are snake teeth.
But the kind of head you're going to find and the kind of teeth you're going to find are not going to be from a viper or a cobra. It's going to be much more similar to that of a blind snake.
Well, what we find isn't similar to a blind snake, which has also been part of the debate. And it's not just my work in this case. Even that Tetrapodophus paper that you were looking at earlier, Aaron, that thing's got Tetrapodophus below blind snakes. We have again more derived than Tetrapodophus.
Again, all I can do is refer back to the studies I'm reading.
Oh, totally with you. Totally with you.
I'm not actually looking at the source material firsthand like you are.
Yep.
But the studies I'm showing is that they say that the boids are the most primitive modern snakes. Oh, except for Scolopophidians.
Right.
Yeah, thank you. So the technically the blind snakes, and then there's like one blind snake that was 9 foot long from 88 million years ago that obviously wasn't blind at the time. It's the size of a modern boa constrictor, but it's still in the class. So that would make it still the more primitive, right?
I'm not sure which one you're talking about that was that big.
I'd have to look it up. I'm sorry.
That's absolutely fair.
It's not the Tanaboa.
Yeah, I want to mention something. One of the things I love about Larry is as you're going through this, when you're mentioning these studies, I'm watching Larry nod, and I know that he's read, because he brought up Fry's research, and I'm just impressed that he had already read the study. I asked Larry to be on the show 30 minutes before you came on. So he had no time to prep, and he's already read all these stories.
Sorry about your luck, Larry.
Yet he has the humility to call himself an amateur.
Yeah, well, I appreciate the invite. I was like, oh, well, I hope I'm not put on the spot, because I wasn't even ready to be on this. But
okay, I'm going to try to get to the remaining 4 questions on here. I don't want to be abusive of your time.
Oh, no, that's fine.
I do intend to write to you more, and I hope to communicate a lot more about this and other subjects. But I want to get through these last few questions, and then I can let you off if you feel like going. Ivory Darkness says, Aaron, your humility is inspiring. Okay, thank you. That was well timed. Good luck with your edits. See you on Sunday. Frederick Agerbo says, what is your favorite sexual dimorphism fact about snakes? And when can we see the first sign of sexual dimorphism of snakes in paleontology? Michael?
Well, we don't see anything in the fossil record, unfortunately, and that's one of the limitations, really, of the fossil record. Almost 100% of the fossil record of snakes is a story about isolated vertebrae. The number of articulated specimens is extremely small. It's illuminating because of the anatomical differences between living snakes and the dozen or so really old, kind of Mesozoic, sort of age of dinosaurs, to put it simply. The anatomy of those fossils is so different than what we see in living snakes, while still being snaky. But we really don't have enough individuals. We haven't found, say, a pregnant version of a fossil boa, so that we would know what a female boa would look like, say, 50 million years ago. We really don't have any sense of the dimorphic features that we see in living snakes. The fossil record is just not good enough.
One of the only things that I could think of with boas is females are bigger.
That's
more or less, yeah.
Yeah, and that's really what it comes down to with crowned snakes, is the females can be significantly larger than the males, but it's mostly a size difference. In terms of coloration, it's not like, phalaropes among birds. It's you can get
there
very
may be some in some species, but it's not. Yeah, it's definitely not.
If you've got one example of paleopython, for example, if you only know that one skeleton, there's no way you could know whether it's bigger than the male or the female.
Yeah, and you wouldn't know from the fossil record if you had, even if you had one paleopython that was pregnant and could assume that here we have an example of viviparity amongst some ancient snake. You won't know if you've got a not pregnant female or a male with the next specimen. So determining sexual dimorphism is just about up there with
it's
no
difficult.
chance.
Yeah, very difficult. I mean, because most sexual dimorphic features, besides size, are really, coloration would be another one. Maybe, in some cases you'll have like, certain species that have horns, or they won't have horns, or, eye, protrusions or things like that, that may or may not be preserved in a fossil record anyway, depending on what it is. If it's bony, because usually it's not bony issues, it's usually keratin or skins or
cornified epidermis.
Epidermis type of issues, which usually you don't find in a fossil. Very rarely you do, but depending on the situation. So it's very difficult to look for sexual dimorphism in fossilized specimens.
Yeah, somebody commented on my humility earlier, and it was only because I prefer to talk to people who know more than I do.
And the thing with the dimorphism is, like, not every snake, the female is larger than the male. Not every snake species. So biology is messy. Sometimes it follows rules, and a lot of times it breaks rules, even in the same group.
The number one rule in biology is that there are no rules. I mean, you learn, honestly, you learn from a very young age about, the central dogma of biology. Well, there is no dogma in biology, when you're talking about,
when have you had
it's DNA, RNA, proteins. Well, when we discovered retroviruses, that whole dogma went out the window. Right?
When is like in taxonomy, for example, when is our classification ever shown that nature conforms to our definitions?
Yeah, exactly.
So Garden Tuber says, why do some snakes have slotted eyes and others have round eyes?
Whew. I'll turn that over to Larry. I mean, wow.
Well, again, like, good question. I mean, there's, again, different.
Is this going to have anything to do with whether they're diurnal?
But yeah, I mean, it has to be, sometimes it's method of hunting, right? Whether you're an active hunter versus a sit and wait predator. We often see vipers and, even elapids that converged evolutionarily to look like vipers, like your death adders. They're all sit and wait predators, and they all have slotted eyes. Whereas active hunters, like, for example, most of your colubrids, most of your lapids, they all have round pupils, and they're active hunters. They actually physically, are usually hunt during the day, some even at night, but all of them have round pupils. And I will tell you that, but there are exceptions to that rule as well, right? So when you look at your vine snakes, I think they are more active hunters, but maybe at night I think they're more active, so there's it's probably has to do with the way they see the world that helps them in hunting. And I think that's really at the end of the day what it boils down to, and that's about as general of an answer I can give without being completely wrong on this. That's the best,
and I can
best guess that I can give without me being an expert in that.
I can guess. I mean, I can see that there is, or I can perceive that there is some speculation, and you're admitting to speculation, and I appreciate that too. Okay, so the next question, the Mighty Jab says, maybe a dumb question. I'm not versed in this subject, but what would be the advantage of losing their limbs? Well, the first controversy was whether snakes lost their limbs because they wanted to swim and I'm saying wanted, which is not this is just going to confuse people. Whether over the course of time, whole populations incidentally lost their limbs because it was easier to swim without them, or it was easier to burrow without them. My thought on the subject, for what little that's worth, is that in all of lepidosauromorph reptiles, whenever they returned to the sea, they lost legs, but they kept feet. So they kept them as flippers, but they kept them because in the water there is some function. So ichthyosaurs, plesiosaurs, elasmosaurs, mosasaurs, and even if you want to go a little bit outside of that to placa, what is it? I forget. But anyway, they kept their flippers, but with a number of lepidosauromorphs, and not just squamates, when they go underground, when they become burrowers, there's a much stronger selective pressure to ditch the limbs altogether, that they don't serve any function, neither as flippers nor as anything else. Just get them out of the way.
Yeah. So that goes down to the original point of why would they? There was clearly a selective pressure, and it has to do more than likely with their environment, right? I mean, that's that, so whether it's swimming, whether it's fossorial, whether it's just they decided that slithering on the ground was better. I mean, who knows? I mean, the same question that's an interesting one is, I don't know if you're familiar, Aaron, with the ice fish in Antarctica, the Antarctic ice fish that lost hemoglobin. What's the benefit of losing hemoglobin?
Yes, the one that
right?
its blood is clear.
Yep.
But it also has a kind of an antifreeze in their blood.
So what's the advantage of, they're the only, as far as we know, the only vertebrate that lacks hemoglobin of all vertebrates, but they lost it. So, and they're doing fine.
Professor Caldwell, Dr. Caldwell, whichever you prefer.
Mike is perfectly fine.
In the script that you have now completely upended, and that I now need to start writing all over again.
So instead of 2 weeks now, it's 4 weeks
I was finished today. And then he started talking. So I'm going to be working on it a little bit while longer. But I offered a hypothesis in the script that I was working on as to why 92 to 100 million years ago, why we have a handful of snakes that only have hind legs, and why they seem to have, and you were working on snakes from 50 million years earlier that you think had four legs, even though we don't have evidence of that yet. Why would they have lost the front legs for so long and kept the hind legs for so long? And now if you look at what they call the primitive snakes, the boids and the pythons, we know that they have the last remnant of the cloacal spurs, which are the last remnant of the pelvis, which they use in sexual stimulation.
And those are actually, I believe, their claws, right? Their finger, the carrots.
The femoral spur, actually.
So it makes sense to me that if they're using them in this capacity now, that 100 million years ago, having hind legs that did the same function that those last vestigial claws do now, that there's a correlation. The reason that they kept the hind legs was for mating.
It's possible. It's possible. The only question then would be if they're essential to mating, why have they been lost in all the colubrids? Because there's no pelvic remnant at all in that most speciose group of higher snakes. I honestly don't know. It's right up there with why lose your limbs in the first place.
Yeah.
And I know you can make a very functional argument about moving in small and tight spaces, and no problem at all. I get that. The argument breaks down a bit when you look at all of the living groups of non-snake lizards, like that genus Larista, that show some degree of partial to total limb loss. Why even keep the legs if you're living cryptically under a rock? Yet they do. You can kind of understand why the ones that have lost the legs, because hanging out in South Australia around Adelaide with my colleague Mike Lee, I've gone out to the Barossa Valley to go wine tasting. And then we go Larista hunting. And all you have to do is turn over a log or a rock, and you're going to find any one of those limbless forms of Larista or other kinds of limb-reduced Australian skinks. They're all over the place.
Well, I have to tell you that studying the little bit of herpetology that I have, and having been to Australia a couple of times, I'm not as anxious to go turning over rocks looking for unfamiliar snakes.
Oh, come on, Arnold. Let's go, man. It'll be fun.
Yeah, it's fun. There's a spider threat and a venomous snake threat, but hey.
I saw your post at your convention where you picked up a cute little green snake. You're like, oh, what's this? Oh, that's a green mamba. Like, oh.
Okay, I'll put that back.
All right, Professor
You look
Caldwell.
at a more basal form like a salamander. They'll have reduced legs or no legs or small legs. It's kind of more like a tetrapod, what you would expect, like fins to develop into legs eventually.
And then when you get into skinks versus amphisbaenians, you can have back legs or you can have front legs.
Yep, some front legs, some
Yeah, Bipes blows the door off all the rules about limb loss. And it's one of the few tetrapods that does. I wrote a paper back in 2003, very long time ago, if I think about it, where I just simply reviewed limb loss in tetrapods, going back in the fossil record of all four-legged critters. And every amphibian group out there, fossil ones going back 280, 270 million years, they show the same kinds of rules about limb loss as do snakes and lizards. In other words, you lose the forelimb first, your body gets a little bit long. The pectoral girdle disappears, your body gets a little longer. And then when you lose the rear limb and throw away with the girdle, that's when you start moving up into those vertebral numbers of 300 to 400 vertebrae anterior to the cloaca. And that rule kind of holds with every fossil group of tetrapods, except amphisbaenians amongst lizards, where Bipes and Bipes canaliculitis all have a forelimb. And it's a big, sturdy, mole-sized, burrowing forelimb. No back leg at all on that thing, but a front leg.
Never lost the limbs, or it was like an atavism where
Well,
some of the
that's
limbs
a
came
$1
back.
billion question.
Yeah, that's a great question. Can
Things come back once they're lost? And the answer is, of course they can.
Of course they can. Yeah. Those toolbox genes are still there.
They don't go away. The genes stay there.
I made sure to include those in my script only because I remember when I was a little boy, and I'm reading books about reptiles, and they show those amphisbaenians. I remember every time I've ever seen those with the ones with the front legs, like those are adorably cute.
Yep,
that needs to be featured. All right, Professor Caldwell, I want to thank you very much for being on the show.
Yeah, my pleasure.
I will probably be bothering you with a couple of other requests for clarifications in email and whatever.
Yep, you bet.
All right, and I'd be happy to have you on again if there's anything else you'd like to chat about, because we do have some other things we could talk about.
Yeah, I think we do have a few things in common.
Larry's our friend, and we always bug him about anything reptile.
Excellent.
And I'm always happy to provide whatever knowledge I have.
Yep, nice to meet all of you.
Yeah, it's fantastic.
All right, thank you much. Peter, take us out.
All right, cheers.
Cheers.